Not yet. So I'm starting, right? Okay, guys. So, hi everybody. My name is Konstantin Yakovlev. I understand that it's always hard to listen to the last lecture before the lunch, right? So, yeah. So I hope to to entertain you. I have a lot of videos in this lecture, so it's kind of there are no formulas, almost no text on the slides, but pictures, funny videos, and stuff like this. And I hope we will have some sort of the discussion here. So let's go. A few words about me. I don't have time just to say that I'm PhD in computer science. I work for Federal Research Center Computer Science and Control, for MIPT, for Higher School of Economics. I'm the member of Russian Association of Artificial Intelligence. My main research interests are somehow connected to robotics, although I'm not like a robotics guy, right? I mainly deal with the algorithms for like pathfinding, for simultaneous localization and mapping, like multi-agent coordination and stuff like this. So yeah, and today we will kind of, I'll try to give a kind of like in sketches like a brief overview of how robotics and AI are like interconnected in my opinion. So the first thing we need to, I want to make it clear. I want to elaborate a little bit on this question: how advanced are the robots so far? Because there is like what I've noticed almost in any room I'm talking about robotics, there is like an AI. There is a kind of misunderstanding about what is actually going on, and so there is this big gap between like expectation and reality, and it all comes from YouTube, obviously, right? So we're all like reading these papers and watching these YouTube videos, and we often see something like this. On the left, there is this robot. Does anybody know what's this robot? Yes, it's yeah, correct. It's Atlas from Boston Dynamics. So they once in a while, this company they shoot some video like this when they have this like Atlas robot doing pretty amazing things. So you see it's doing like backflips, and of course when we see those videos we're kind of like we immediately get scared, because that's the point where like they will take over the humanity, right? So we're in trouble. So the robot is doing backflip, right, on this video. So this gives you kind of an impression that robotics is like robots are really advanced so far nowadays. But the truth is that more often it happens like this. So it's the same robot, right? So it's the same robot, and it's pretty like a simple task to put this box somewhere. But he got confused, and then in the end of the day it falls down. And I'm assuring you that it's really hard for those robots actually to get up, right? So so those two videos, they kind of like actually show what is the difference between like expectation and reality. We do not actually know how many tries it took the creators of the Atlas to shoot the video like the one on the left, right? But although as I've said, I'm not that like more into mechanical parts, into robotics, but I know that those robots, they really work like once in a while. So it takes like 1, 2, 3 days, like a week, to actually get the things aligned right, so your robot actually performs well. And in like 90% of the cases, it goes like this on the right. So and there is like even more big problem with this. So this is all is shooted in kind of like lab environment. So this is in the lab where everything like is like is nice and clean, and the light is good and stuff like this. So there was this competition of robots in 2015 where these robots were first to go out of the lab. So they were competing in like basically in some basic tasks. So they need to like to go through those derbies, or to open doors, or to push buttons. So actually like pretty simple tasks, but not in the lab environment. This is very important. Not in the lab environment. And basically like there were a lot of robots that were just like falling down, and like basically, yeah. So you see this robot, he thought that there is you know, like a door somewhere on the left, but it is on the right. So, and that's basically it. So when we look at these nice looking videos of the robots who are doing backflips, we need to realize that this is a kind, you know, like once in a while in the lab environment it happens so. But I mean, like in reality, it's more like this, right? So you see these guys, he's thinking that he's kind of, you know, like doing something with the valve. Yeah, it's actually like, this is the robot which actually won this challenge. Robots do not like me. That's true. Okay. Are we cool? I won't offend you guys. Okay, so this is the robot which actually won this tournament. It's from Korea. So I was in the same year in 2015 later on in this lab, and we asked the guys to show us how this robot is actually cool. So, and the task is to, you know, like how to, you know, like to go through this, you know, like uneven surface. So it really takes him a lot of time to actually calculate like the movement. So he's just like calculating how should he like do with his leg, and in the end of the day, only because of, you know, like of those two like PhD students from Korea, it actually did not fail, right? So that's the reality. And I have a lot of evidence like this. For example, I was in another conference in Pittsburgh, and in 2017, and at that time they were Uber. They actually had like two headquarters in the U.S. One is on the obviously like West Coast in California, another is on the East in Pittsburgh, because in Pittsburgh they have this Carnegie Mellon University, which is really cool in this, you know, like AI and robotic stuff. So they hire a lot of people from Pittsburgh there, and they were actually, you know, like running Uber's driverless in this 2017 when I was there. So this is like the actual picture of this Uber driverless car, and this is the exterior on the left, and the interior is on the right. So what do you see, guys, on the right? I mean, like, who is sitting in the driver's seat? Is there someone? I mean, I understand that the picture is like not clear, but I mean, like, so it's the same car, the driverless car, like I took the photo from the inside. So what is on the left? Yeah, the driver. I mean, like, yeah. So there is a human, right? So there is a human in the driver's seat. Yeah, it's true. So it's the task of this human is, you know, like to intercept the control of the vehicle in case something goes wrong. And I mean, like, it's actually a good idea, right? Because we do not want, you know, like those cars on the streets without any, you know, like supervision by human, at least when they're in this testing phase. But I mean, like, if you have like a closer look, you will probably see something unusual on the right. So does anyone see what is going on the right part of the picture, or have any guess what's there? Well, yeah, a laptop. Yeah, that's true. So there is a laptop which actually shows how the intelligent control system of this car is running. So okay, the laptop, and what else? Who is carrying the laptop? Yeah, another human. That's, I mean, like, it's not clearly seen here, but there is another human at the passenger seat who is carrying the laptop, who is connected to the control system on the car, and actually, like, look at what's going on. So just think about it, like how advanced robotics is nowadays. I mean, like, for a driverless car to drive, we need two people controlling this car, right? So when I'm driving from my home to here, I mean, like, I'm the only one in the car, right? So for driverless car, so good so far, we need like two people. That's kind of cool. I mean, like, it makes me feel really good, because it kind of gives me a sort of, you know, like thought that my job is kind of secured, right? So I mean, like, and it actually creates jobs for you. So basically, my main point of this, you know, like, short part is that don't, you know, like, be scared when you see those, you know, like, videos on YouTube, because when it comes to real life, it's much more complicated. Just trust me, like the guy who deals a lot with this stuff. Another thing which is always, you know, like, confusing about this robotics, AI, and stuff like this is that actually no one knows what is a robot, right? So I mean, like, if I ask you, like, how many robots do you see on this slide? What will be your answer? Like, how many robots is on the slide? So I've like 4. Any other ideas? 5. What's the 5? Where's the 5th? Ah, there are 2 these manipulators there. Okay, like 4, 5. Okay. More than 1,000. So basically, all of us kind of agree that all these guys are robots, right? So I mean, like the point of that, but they kind of look really different, right? So I mean, like some of them look like a human, some of them look like a dog, some of them look like, I don't know, like an UFO object and stuff like that. So here I just, like, so when it comes, when you try actually to give a precise definition of what robot is, I mean, like you're in trouble, right? So I've put down here on the slide a few definitions of robot that were that I've taken from some scientific papers, from vocabularies. So it's not like like some consumers or I don't know, like your Aunt Merge in the supermarket gave these definitions, right? So they are all from like respectful researchers, and they are all different, right? So I mean, like if you look at the definition number 4, you will see that it has something to do with a human being. There is like a really like general definition, for example, number 3, a mechanism guided by automatic controls, right? So when you look at this, it can be anything, right? I don't know, and it's actually true. I mean, like if you try to think of like precise definition of a robot, I would argue that this guy will be a robot, right? So I mean, that's the mechanism which is guided by automatic controls and stuff like this. So it's really hard, like to figure out what the robot is. So for the purpose of this lecture, we won't consider like coffee machines, like some primitive like drying machines as robots. We won't consider like humans as robots, and we won't consider like laptops as smartphones as robots. Otherwise, things will get like really complicated, right? Although, as I've said, it's really hard to give a definition that your like washing machine or say laptop is not a robot. So you basically cannot come up with such a definition. At least like in one sentence. Maybe it's going to be like a whole book about it. So maybe that's a good idea. Like what typically I like is to kind of narrow down the whole thing. So not talking about like robotics or some like robots in general, but like to talk about some like more narrow class of robots. So this is typically done by like when you put some adjective before robot. For example, here, so we see those mobile robots on the left, and non-mobile robots on the right, this manipulator. So the main difference between those robots is that the robots on the left, they can do what? What is the main feature of mobile robots? Yeah, move. They can move, right? So they can move themselves from one place to the other place. And this guy, this manipulator, unless it is installed on some mobile robot, but typically it is just like like fixed, and it can do some movements, but it cannot move itself like in general in a whole from one place to another. So actually it's a really good idea when you're at least like talking to someone, or like when you're arguing with someone about robotics and stuff like this. It's a really good idea to actually to maybe do not try to like to give a precise definition about what you're talking about. Just ask like about what kind of robots you are talking about. So this can be like industrial robots, wheeled robots, flying robots and stuff like this. So this is much more productive in my opinion. So when you like you kind of specialize in. And the thing is that we want to talk a little bit about what is like what will be called intelligent robot, right? So like AI, robotics, and stuff like this. That's a funny thing here too, because like many people actually like got confused, and they think that AI and robots is the same. So I mean, like if you ask some if you ask a random guy on the street about like robotics, AI, and stuff like this, there will be a kind of I mean, like the picture which comes to everybody's mind is something like this: robots with AI conquering like the humanity. That's the point. Obviously, I hope that, I mean, like, you understand that those actually two concepts are quite different, right? So these are not the same things. So, for example, can you give me an example, like, not just like an example where, for example, we have a robot, but we do not have AI, and no one can argue that we have a robot, but no AI in this robot. Yeah, for example, industrial robots, those, like manipulators and stuff like this. Yeah, that's a good example. I actually have another one, but it's still, but the thing is still. So for example, if you see these flying machine drones somewhere, if you look around, typically you will see a guy who actually controls the robot, like 100% of the time. So I mean, like we do agree that this drone is a robot, but it is controlled manually by an operator, by a human, right? So those class of like teleoperated robots by a human, we have like a lot of teleoperated robots, and we obviously cannot call them that they're like intelligent in some way. They're not supposed to be. And so we have these remotely controlled robots like surgery robots, for example. A lot of space robotics is actually like remotely controlled. Those industrial machines that you were talking about. And okay, and vice versa example, when we kind of have an AI system but there is no like robot involved. This is really easy actually. Yes, yeah, some sort of like for example some virtual assistant. We all agreed that like our phones, smartphones, and laptops are not robots. So basically, when we're running this sort of the program on our laptop, or just like the automatic translation, we know that to translate automatically from one language to another is a problem that is attributed to be studied within AI domain. So I mean, like people who study this problem, they have always thought of themselves as they are kind of doing AI. And I kind of agree with this. So there is an AI here, but I mean like no robot. And yeah, and other examples are like this, all this, like chatbots, or like virtual assistant, text translators, yeah, and stuff like this. So basically, what makes a robot intelligent? That's where we start like going down to the point. And actually, to narrow down the more now I'm asking not about like the algorithms or like AI and stuff like this, but what are the features of the intelligent robot? I mean, like if you do not know how it was built, what is the software inside and stuff like this, but still you need to somehow distinguish the intelligent robot from non-intelligent one. With what features? I mean, like for what features would you look at? What features are you looking at? So that's an open question. So. Does anyone have? Okay, so I'll just like it's let's make it like a brainstorm. So okay, so autonomous and that's a good point. I really like it. What else? Rule based, goal oriented, right? Goal based. Okay. Non-deterministic. What do you mean by non-deterministic? To react. Able to react. I like this. I'm not that sure that I really like this thing, but able to react, I really. Sorry. It was funny. What else? Creative. So creative. Okay, what else? Ability to make decisions, making decisions, learning, adaptive. Yeah. Okay, guys, you're really cool. So I'm here a lot of words which I actually agree upon, and a lot of these things are actually on my next slide. So this is not like a universal thing. So that's what I typically like wanna kind of see from robot being intelligent. So the first thing is, yeah, I completely agree that I mean like it should be autonomous. So I mean like autonomous means that it can can operate in complex environments without human supervision. at least for some period of time, right? So actually there are, in those, like, scientific fields, there are guys who are kind of, like, subdividing autonomy to kind of quantize autonomy to different levels. So you can find the like papers where we have, like, autonomy level 10, autonomy level 5, and stuff like this. So yeah, but basically, yeah, we want a high degree of autonomy. We also want, like, the ability to adapt. To adapt, of course, we need to react, to be creative, to learn, to make decisions and stuff like this. So I would say that this ability to adapt, it kind of incorporates these things like learning, creating, and stuff like this. And another thing is the ability to collaborate with other robots and ability to collaborate with humans. Why do you think I've put last two bullets kind of separately? What is the difference between? They are all about, like, interacting, right? So maybe I should put it to... Yeah, so the principal thing is that, for example, robots, they can communicate and collaborate with each other in their own, like, languages, in zeros and ones, and it will be, like, kind of perfect. So it's going to be, yeah, okay. But if you're expecting the robot to, like, to interact with humans, it means that it needs to, like, to understand human language and all other, like, even more, like, high level, even like cognitive stuff. So basically, if I was asked what is, like, an intelligent robot definition, I would, like, just, like, glue those things together, and we'll come up with this sort of, like, of the definition. So it's like a programmable device, blah, 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 capable of, and stuff like this. So basically, that's the features we're expecting from intelligent robot. And now the main question, how to achieve this? Okay, so we now know that we need those adaptive robots which are, like, autonomously operating in the real world and collaborating with each other and humans, blah, blah, blah. So how do we make such robots? So what is how to achieve this? I mean, like, in general, what we need to do? What's that? Yeah, we need artificial intelligence, right? So now we came up to another, like, topic, and what is AI? So I know it's kind of weird to raise this question after 4 days of lectures, hackathons, and stuff like this. But actually, it's really important question, and the importance is like, so we even decided to have, like, which is not still, I believe, on the program, but I believe that at the closing ceremony we will have, like, some sort of the panel discussion with you guys also involved, a high-level conceptual discussion after all lectures were heard and stuff like this, to get kind of, like, maybe share some thoughts about what is AI. So I will kind of skip this part, but because I won't be, it looks like that I will be kind of moderating this discussion, so it means that I won't be able to share my own opinion. I will, yeah, because I'm talking now, so I will, for example, say what is AI for me? So I'm like kind of a guy from academia, right? I'm doing research. I do not have a startup. I'm not like Elon Musk or someone. So, and I know that actually AI is rooted in science, right? So I mean, like, it were like scientific guys from academia who actually invented the whole thing. So it was not Google, it was not Huawei. I'm sorry, yeah, but it was guys from the universities who actually start investigating like this topic. And basically, from my perspective, from like scientific perspective, AI is just a scientific discipline, right? So it's just like chemistry or mathematics. So when I hear, I mean, like when I'm reading in the Russian, especially like, you know, like newspapers, that they created car with artificial intelligence in these, you know, like big letters. In Russia, we do not typically write, you know, like something in between the sentence in big letters. I kind of get confused. It's something like saying they invented the car with, I don't know, mathematics, right? So it just doesn't make any sense for me. Of course, the result, the people who are like me who are doing this research, obviously the result of their research is likely to be implemented as some software and embedded, you know, like into some system, or some technology will be created, but not, I mean, like not vice versa. So we first study, so AI is just like a field of studies for me. But I understand that it's a kind of, you know, like very, you know, like arguable position. So that's the thing. But I have supporters, right? So for example, if you have a look at the say any course, introductory course to AI, say, I don't know, like in Berkeley or MIT or whatever, they would typically recommend this book as a handbook for Intro to AI course. This is the book written by Stuart Russell and Peter Norvig, and which is like called Artificial Intelligence Modern Approach. It has several editions, and on one of the editions, I believe this green one, this book has a subtitle. So they have this AI, the Intelligent Agent book, right? So basically, AI, from my point of view, is a scientific discipline that studies the behavior of intelligent agents. It's a broad definition, I understand, yeah. So an agent, it can be like anything. It can be like a game character, right? Like this guy. Or it can be a robot as well. The thing is that we typically wish to, you know, like to abstract from the, you know, like whether it is a virtual agent or real agent, because we're actually are interested in what is going in between this interaction of the agent with the environment. You've probably seen a lot of pictures like this. When we have an agent, I mean, like it receives some, I mean, it has some sensors and it senses the environment. Then some magic happens in between, and I mean, like it performs action, right? So that's the concept of, you know, like of an agent. And this agent, I mean, like it has to do like a lot of these deliberation problems that, which we're solving inside this, you know, like AI agent. I mean, like they're plentiful. So it's not only, you know, like learning, right? So we also need, you know, like to think about, you know, like after you learn, what will be your knowledge representation? Some general stuff like reasoning, planning, communicating, and stuff like this. So it's not only limited, you know, like to learning or like to recognition. Yeah. So I will, yeah, this is basically like the two-circle diagram showing that actually the robotics is a big thing, and a lot of robotics is not like about AI and they're just making robots. A lot of actually AI people, they do not target their methods to be implemented on the robots, but there is something in between, and this is a nice place to be, I think. Okay, I will skip this, skipping. I do not have time. So basically, if we are talking about how do we, you know, like make a robot intelligent, we need AI. AI is like science, but the result of this research is something is basically like the software. So basically, we need to create, you know, like the piece of software called intelligent control system. So that's the system which kind of you know, like which is running on this robot and basically receiving this sensory input and telling the robot what to do. And it's a complicated piece of software. I'm just showing you like one of the possible architectures of this software, the one which we're developing in our lab. So this is layered, like so you have like 3 levels of control. We call them strategic, tactical, and reactive. So basically, the more higher you get to the top, the more kind of intelligent processes you're thinking about, right? So at the very low level, you have, you know, like basic tasks which typically people in robotics like the one on the right. So just like, for example, stabilizing the system. So there is a lot of, you know, like control theory in this, but yeah, so not that much of AI probably. So just, you know, like stabilizing the system. Or for example, another thing is like about path following. Will it start? How do I want to fast forward because I do not have time for all these, you know, like. So this is basically what is going on on the lowest level. So when you have already a map and a plan, someone has provided you with the map and the plan, and you need basically to drive your robot according to this plan. It's actually not an easy task. You need to compute how fast your wheels should rotate and stuff like this. So it is also like a software. I mean, like it is also a part of this control system, but it resides somewhere, you know, like on the bottom level. And typically we don't think about those methods as, you know, like as AI methods. They're kind of, you know, like just controlling. Maybe the methods that create the map and the route may be attributed, you know, like intelligent. Yeah, that's basically if you think about like about this, you know, like second level. In our system, this layer in the middle, it is in charge of, you know, like all sorts of navigation stuff. So yeah, I do not have time to show this, sorry. So what we're doing, for example, in our lab, so this is the task when you have to, from a single camera, you need to create the map of the building, right? So you do not have any GPS or stereo cameras or stuff like this. So what and it's all running online on this NVIDIA Jetson small CPU. So we are kind of reconstructing the depth. So you see that the depth of the image is reconstructing, and we're kind of gluing together those depths and obtaining the map. Okay, then we have, I'm skipping this. Then we have path planning. Once we have a map, we need to find a path. That's what we are kind of, you know, like do a lot in the lab. That's what I personally like. So yeah, and we do a lot of multi-robot things. My collaborator Ronnie Stern had a lecture on this. Yeah, that's the picture from our paper, joint paper, which was accepted to each guy. So you see, we can allow our agents to move only, you know, like in cardinal directions, or either we can robots move in any direction. And obviously, it's better to do, which is something, yeah, on the right. It's our kind of like the last achievement, which we're really proud of. Is it the same? Yeah. Okay, and just the last but not the least is this high-level deliberation tasks. So they are all about, you know, like for example, like the behavior planning. So not about where you should go, but about why you should go there, right? So that's also an important question. And for example, we have this, you know, like idea of cognitive communicating robots, where you have like a group of robots with different abilities, and to successfully solve the tasks, they need to help each other, and they need to share the knowledge. And we have a special like knowledge reasoning and knowledge representation model called sign-based model, which is deeply rooted in like all those cognitive things. It's Alex Panov who is doing this thing. Yeah, and obviously I cannot avoid this topic about this hot trend about like machine learning in robotics. And it is doing really well for these sort of robots, for manipulators. I know that, I mean, like machine learning for manipulators, specifically like reinforcement learning, it's really cool. So you can, you know, like robots, those manipulators can learn from scratch to grasp some objects. But for example, in case you're talking about like SLAM and pathfinding with neural networks, it's not that good. Still, I mean, like, still we better stick, you know, like to traditional models. That's also what the topic which we're trying to solve in the lab. For example, my another student of mine, she was doing this, you know, like generation images as path planning. So we are not planning a path as typically we would do in robotics with like a star or some algorithms, but we're just showing the picture of the environment and start and go, and ask the neural network to kind of generate our new picture. So it works for small maps. At least we were able to achieve this. And others, yeah, do not have time for this, sorry. So yeah, that's I will just run this video, but this concludes my talk. This is This concludes my talk. So in case you have like any questions, you can ask them now. But basically, we're out of time already. Sorry. Okay, so no questions. Thank you very much. And I think what we need to do now is a big photo of all of us, right, Alex?